Hello, and welcome to the Semiconductor Industry Association's public webinar series, where we address current issues impacting the global semiconductor industry and market. My name is Falani Nug, and I am the Director for Industry Statistics and Economic Policy at SIA, and I'll be your host and moderator for today's webinar. One exciting technology that semiconductors are enabling is the fifth generation mobile network, also known colloquially as 5G. What makes 5G such an exciting technology is similar to semiconductors themselves. It is a foundational technology that offers tremendous potential to profoundly impact the US economy and the world for that matter. According to a recent Accenture study, between 2021 and 2025, 5G will drive up to $2.7 trillion in total new sales across all major industries in the United States, create or transform up to 16 million jobs, and drive up to $1.5 trillion in GDP. And semiconductor technology is at the heart of enabling 5G's transformative impact on the US economy. We are fortunate to be joined today by a group of distinguished panelists for a conversation on how semiconductors are enabling the 5G revolution and what 5G means for the US economy. Mr. Jefferson Wang is Global 5G Lead at Accenture Strategy. As Accenture's Global 5G Lead, Jefferson focuses on the convergence of business and technology. For over 2 decades, Jefferson has worked with network operators, original equipment manufacturers, content owners, and technology providers to create executable growth strategies through the end-to-end product lifecycle. Jefferson is also the lead author of the best-selling book, The Future Home of the 5G Era, the first book written with the user at the center of the 5G story. Hi, Jefferson, and welcome.
How are you? Thanks for having me.
Mr. David Robertson is Fellow Senior Technology Director, Automotive Communications and Aerospace Group at Analog Devices Incorporated. Since joining Analog Devices as a new college hire in 1985, Dave has worked in mixed signal data conversion circuits and system ASICs for defense, communications, consumer, and automotive systems. He holds 15 US patents and more than a dozen published peer-reviewed technical papers, and he is senior member of the IEEE. Welcome to you, Dave.
Thanks, Fallon.
Finally, Charles Schroeder is an NI Fellow at NI. As a business and technology fellow, Charles works across the company on key business and technology-driven initiatives. Schroeder consults with executive leaders and department heads, including those from marketing, sales, and R&D, to drive the company's strategic direction, development, and future growth. With a focus on long-term innovation, best practices, and processes, he currently leads NI's efforts to find groundbreaking solutions to the test challenges introduced by the adoption of 5G cellular technologies. Since joining NI in 1995, Schroeder has held various positions, including Vice President of Product Marketing for RF and Wireless Communications, and leadership roles across the RF, modular instruments, DAQ, and IMAC vision product lines. Welcome to you, Charles.
Thanks, Fallon.
Jefferson Wang of Accenture, let's start with you. I mentioned the seminal report that you co-authored earlier this year on the economic impact of 5G. If you would, just give us a brief rundown of the report findings.
Yeah, absolutely. And thanks for having us, Fallon. And I think some of the key findings were really to understand what's the promise of 5G. So we wanted to walk through some of the executive highlights. This was a economic impact report for the United States as well as Europe, and it was done in partnership between Accenture and Qualcomm. So maybe if we can go to the next slide, please, we'll kind of dive into it. So really, as Fallon had mentioned, when we looked at this, it was really driving what are the different ways that we can use 5G, what are the consumers looking at in terms of 5G, and actually how are new enterprises going to really understand or figure this out. And some of the impacts that we looked at, and Fallon had mentioned it, right? What is the actual US gross output increases or sales increases? What is the actual GDP additive that we can expect? What are some of the full-time, part-time, temporary jobs that we could actually create or transform? And then when you look at kind of the key questions we were trying to answer out of this, if you don't mind going to the next slide, please. There was 4 key questions that Qualcomm and Accenture were setting out to answer, right? So the first one was, will 5G really be transformational? Is it going to be this force for growth and resiliency in this post-COVID environment? So as we come out of COVID, as we go into a hybrid work environment, as we start to continue on accelerating virtual health, what are the different ways that 5G could actually drive this out? Number two, what are the consumers looking for? Are they looking at 5G as simply just faster 4G? Are they gonna really need to just download a movie faster? Or do they actually understand what else we can do from a consumer perspective? And then number three, how do we think about industries and 5G? And I think everybody talks about the big promise of 5Gs in these industries and driving into manufacturing, utilities, healthcare, finance industries, and agriculture. But in reality, those are still just the promises right now. And the challenge that we're running into is that because 5G is so flexible and personalized, where do you start? And how do you look at the actual industry specifically and the use cases? And how do you look at the value chain? For example, with the semiconductor industry, if the standards have already been set, how do the semiconductor industries work together with the rest of the value chain? The network operators, the system integrators, the device manufacturers, the actual solution providers, the cloud players. How does that chain work together to really transform these industries or realize that promise? And then finally, can 5G be really the accelerant to get there? What type of policies do we need to think about that need to be changed or driven out to realize that? So the methodology we took was number one, the traditional economic modeling to figure out the sales, GDP, and job impacts. Then we interviewed deep industry experts, the C-suite of folks in manufacturing, in utilities, in all the key industries to really get their pain points, understand what their problems are, and then understand what their current level of understanding of what 5G can do. And is it different than Wi-Fi? Do you need an over-shielded Ethernet? How do you deal with it in a hybrid scenario where you already have the machinery set up and it can't move? We also interviewed consumers. So we did 3,000 plus survey respondents around their understanding of 5G, and we'll share with you some of those key findings today. Can we go to the next slide, please? So really, we'll give you a link to the report. We'll give you a link to the website. But for each of these, this was, the US GDP and job impacts by state, and you can click into it in an interactive map. Same thing for Europe by country. What was the 5G potential impact on GDP and jobs? But I think the interesting and exciting part is that there will be these newer jobs created, and we'll talk about that later in Q&A on what does this mean from a talent and organization perspective. What does this mean in terms of upskilling folks into these different jobs? How do we actually transform ourselves even as an industry to meet this demand? And then could we go to the next slide, please? So here's just a sample of just 6 industries we picked. We don't have enough time to go through all of them, but just some of the US and Europe highlights by industry. And if we look at manufacturing, just each of these industries isn't created equal. Obviously, manufacturing is a massive industry, but what's interesting is that when you look at all the key industries, the percent change of how 5G can impact is very similar, even though the size of each industry is very different. So if you just look at manufacturing, huge industry, what are the opportunities to drive cost savings out of manufacturing? What are the potentials to increase asset life through predictive maintenance? How do we think about defect detection early on? And those are strongly correlated, right? If you detect a defect early, you could potentially increase the asset life. How do we actually go through that? And we'll walk through some of the use cases in the next couple slides. When it comes to healthcare, this value chain is completely different, right? There's so many players in healthcare from a value chain perspective. There's providers, there's insurance providers, there is subacute rehab centers, there's integrated healthcare providers, there's the employers that are paying the insurance providers to supply the healthcare. There is, us as patients and as consumers of the healthcare. That if you look at this value chain, very different than manufacturing. What's the opportunity to improve the outcome? What's the opportunity to improve or reduce going back in for the same health issue that 5G can unlock? So, each of these not only is a size difference in industry, the value chains to each of these are incredibly different. Automotive, what's top of mind for everybody is generally, hey, L4, L5 autonomous driving will save lives, and absolutely is true. But then, if you remember the first discussion we had, there is policy changes that need to happen. There is governments that need to support this, because right now, state by state, everybody has a different policy on full autonomous in a urban environment, not on a highway. So there is definitely technology enablers. There is definitely a need for the actual use case and the solution, but at the same time, some of these are dependent upon policy. And I think that's an important thing to pick up on. Now, again, automotive as a value chain, if you look at how these electric vehicles are created and you look at how autonomous vehicle software is getting updated, even the production of it has an opportunity for 5G. When you look at a car rolling off of a line, it takes a massive data shower. And this is something that we didn't have to do 20, 30 years ago, right? That value chain for automotive has been the same for a long time, but now it takes this big data shower before it comes off the line. And is that being done in the most efficient way, the most cost-effective way? And what happens when you have to update the software over the air? Is that being done in the most efficient and cost-effective way? And then finally, for automotive, how are those vehicles going to communicate with infrastructure, with the other cars around it? Is this a mesh solution? Is this going to be to V to X or CV to X? How do we work those out through 5G? So I think that's the exciting part of automotive. Fourth is really utilities, and this I always find a lot of fun in, because we work quite a bit across all of these with 5G, but utilities is interesting. This is like the absolute most plumbing of plumbing that people think about. They're like, yes, power, I need it, so deliver it. But in reality, there's a lot that's transforming in utilities as an industry. So 15 years ago, Accenture was working with a lot of the utility companies around how do we actually deal with the AMIs and the smart meters and delivering that. And after, as we look at it today, those are getting refreshed. And before, those were just send a signal with some data that says your usage is this. And there was no interaction. There was no need for a broader network play. It went to a concentrator. That concentrator went to a field area network, and then it went back to headquarters. But it simply took a part of the actual need to have people walk around and check your meters. I'm sure people on the phone may not even remember that, but that saved cost, that saved money, and created automation. However, now, as we revamp all those advanced metering infrastructures in the next couple of years, how do we make it more bidirectional? How do we make it interact with the autonomous vehicle that's sitting in your driveway? How do we make the smart meter interact with the actual city infrastructure or suburb infrastructure that you're living in? Well, that requires a different network. It requires different use cases. How do you deal with a field network, a field area network that has to de-energize a line because there's a lot of windstorms coming and it knocks down the power line, and all of a sudden you started a wildfire? So there's a lot of opportunities in something even around utilities that we find really exciting. When you look at retail, certainly we can bring more an accelerant to this physical digital retail environment for next gen. How do we actually make it more immersive? How do we make sure that we're able to drive out retail in a different way? And again, this is almost like a defensive weapon for brick and mortars. How do we actually figure out this hybrid environment? Agriculture is also one of those where you might think, how does 5G fit into agriculture? We may not even get connectivity. You have to kind of get into, okay, do we need a private network or not? If you are going to do a private network, what are the opportunities around it? And sustainability is incredibly important right now. So how do you use technology to drive higher yield? How do you use technology to be more targeted in your pesticide distribution or de-weeding, so that we're not blanketing out that entire field, but being more targeted? And how does it keep people safer, but also decrease costs? So, just some of the key highlights and takeaways. Hopefully everybody will download the report and you can get to kind of the rest of the industries as well as the rest of the use cases. Could we go to the next slide, please? So here's some of the key use cases, right? Those are kind of the key takeaways. So as you get to the use case, I'll just highlight a couple of these that we're working on and building pilots and building solutions around. For manufacturing, millions of dollars spent on worker safety, on making sure that workers are productive, but also safe. And there's lots of issues with OSHA violations or much worse. So how can we use 5G's network plus a video analytics solution that we built on a cloud provider's edge to solve worker safety? And from that, can we stop or can we not allow the machine to start unless you're wearing your eye protection and your helmet and your protective gear. If you're not set up, we shouldn't even start the machine. If you do, heaven forbid, touch a piece of machinery that's moving very quickly or there's a threat, how do we instantly cut the power to say, hey, Jeff, you just touched that, you're about to get spun up into the machine. This is a serious health issue. How do we stop that instantly and take care of the low latency from that perspective? Healthcare, virtual health, this goes into the value chain discussion, that it's always been possible. It's always been a need. But until COVID accelerated insurance providers who are going to actually pay for this, it wasn't realized. So now we find that the newer generation coming into the workforce now, so Gen Z, Accenture did a research study, about 41% of Gen Z actually prefers the virtual healthcare or the digital health experience. So that's something very new, right? My generation has always been used to primary care. You had to go to primary care, in fact, to even get a referral sometimes, depending upon your insurance company, to get to the next doctor. So we're very used to in-person, driving to the actual doctor's office, sitting and waiting, seeing the doctor in person, rescheduling the next one, follow-up, getting the referral, right? I mean, if we can do this virtually, are we saving time? Are we driving sustainability? Are we pushing out the fact that we don't need to drive more carbon emissions as we drive to these healthcare providers? And can we extend the healthcare providers' expertise in a different way? Can we democratize the best healthcare so that it's reaching all the people that need it, versus the true skilled healthcare workers may not be able to reach some of those patients? So, what are the opportunities there around that? And then I'll just pick one more, just utilities, right? For example, as we get into intelligent grid modernization and the new grid modernization, what does that field area network look like? This industry is incredibly interesting because they've always been used to deploying a private network in 900 in the US and in other parts of the world. Utilities has also had a mechanism to actually deal with CapEx. So, each of these utilities has their nuances, but certainly each of these value chains are very different. I think that's important to take into account as we think about 5G. So when you look at this spread, again, this is only 7 industries, not even the double digits we looked at in the report. But what's interesting is that 4G all the way down to 1G was really set. It was one network, a general form factor to many users. And that focus allowed the industry to move fast and scale. 5G is a little bit different. We're opening up and democratizing part of the network. You're finding the use cases much more than just consumer. And as a result, it's much more beyond the application layer to solve at the enterprise state. So that is a blessing and a curse. It is an absolute blessing because now we can try and realize these use cases you guys see on the board, as you know, but also where do you start? Where do you prioritize? What's the actual first use case or industry you go after? How do we figure out how to realize these things? And the traditional value chain of chipset to embedded to device into operating system onto network into cloud, that changes. And when you look at that, how do we try and work together better to accelerate and realize this? So if we can go to the next slide, then we jumped to really consumers. So this was the second part of the research study in the white paper we did. And when you look at consumers, the benefits are pretty clear. They're excited. Consumers are excited about enabling more work from home, bridging the digital divide, new services. On number one, how is connectivity really fundamental in this exercise? Is essential, especially out of the pandemic. There was a lot of trust built with the service providers around this because they found connectivity was reliable, it was up and running, data caps were removed, bills were forgiven. There was a lot of trust built up in number one. When you look at number three, but the US consumers definitely realize there's digital divides, even in cities today. So in our research report, we found that even in large million-person cities, there were parts that didn't get the right connectivity they deserved or they needed, and it wasn't just available. So, how did we have to see that? It was in the kids' education. A lot of times when schools went remote, we saw that right away, that there was buses with, Wi-Fi access points put on so that we could reach some of these. There was, kids in parking lots to try and get connectivity from a McDonald's or another food service provider so that they could get onto their online class. So even in cities where we think connectivity is robust and reliable, it's not quite there yet. So that's incredibly important. I think the real interesting takeaway, though, in our report is that 5G does require more conditioning of the market. And it is a good conversation to discuss because it's not just faster 4G that we're getting to. So if we could get to the next slide, please. So this is, I think, the last slide before we give you the links to the reports. But when we say an image problem, if you look at these numbers, it's basically showing that majority, at least almost half of the US population, and it's roughly the equivalent in Europe, knows about 5G. So we still have a long way to go in terms of addressing the campaigns, the marketing, and the awareness, and driving up the awareness of what 5G is coming. And for everybody on the phone, this isn't new for anybody because we've gone through this 4 other times before in 1G to 4G. But as you start to move this into the industries, they're not used to this. So the industries, like a manufacturing plant, is not used to the fact that, what do you mean I'm going to have to upgrade my devices? What do you mean I'm going to have to upgrade these things? We are, right? So we've created incentive plans. We've created 4G is still around, 3G is still around until maybe early next year where we start to sunset 3G, but, and reform the spectrum. But the new industries that are about to get into cellular aren't used to that. I'll give you an example. Construction. If they have equipment that's supposed to last for many, many years, and every 30 years we're sunsetting something, and all of a sudden they have to either deploy a technician to upgrade that piece of device of equipment to get the new connectivity, or they have to rip off the module and replace it. That is not something they're used to. And you can't bring those pieces of heavy machinery into a service center. They're massive. So that's something I think the cellular industry and the wireless industry is used to. But as we move this, as we democratize this out to other industries, we have to almost share the lessons learned, make sure the processes are set, and explain to them actually how we've done this to give them confidence that this is something to go after. On the consumer side, though, the expected impacts, this is a little bit troubling. Over 50%, around 50%, don't understand what 5G could do besides speed. And that should lead to a good conversation around the device ecosystem, where semiconductors have a great play into that. Smartphones, of course, are going to continue. There's nothing that's going to happen to that. But as we get into this post-smartphone era for consumers, what does that look like? Is it a hearable? Is it a wearable? Is it a piece of equipment in your home? Is your home a new IoT hub that we need to be thinking about on cellular, not on Wi-Fi? Or if it is on Wi-Fi, how do they coexist? So I think that there's a lot of questions that we need to crystallize to really accelerate all of these. But it's an exciting time. It's an exciting industry, and I'm very, very grateful to SIA and Phelan for inviting us here. So if we look at the next slide, this is the 2 links to, one is the website where you can find the report for the US side of things. And the second one, you can just download the European report from that second link.
Awesome. Well, very much appreciate, Jeff, you starting us off and putting a lot on the table. Obviously, if folks haven't checked out the report, please do. There's a lot more in the report, and hopefully we can drill down on a few of these items during the Q&A. But yeah, super rich detail and great information. Next, I'd like to turn to you, Dave Robertson of ADI. I want to move backwards. So Jeff's talking about 5G, how it's enabling US economic growth and jobs, but something's enabling 5G, right? And that's obviously semiconductor hardware. So I wanted to see if you could just talk a couple things, maybe a bit broadly about, in general, how semiconductors do enable 5G, and obviously more specifically, what ADI's role is in making 5G part of that, part of our reality.
Yeah, thanks, Fallon. And thanks to Jeff for kind of setting the stage here and showing the enormous economic impact that can be had here if we can just make it work. So I'll try to have Fallon share the slides.
Okay, 1 second, hold on. There you go.
Great, and just a real quick, it's coming up. I'm not seeing it. Maybe that's my Zoom mode.
Oh, okay. Can folks see the, yeah, we
Jeff's
see
seeing
it.
it. All right, Jeff's seeing it. All right, good. So just a real quick introduction of analog devices then. Um, we we're a mixed signal semiconductor company. So we make the analog RF mixed signal stuff, the sensors, basically all the stuff that sort of sits at the edge between the real world and the cyber slash internet world. And that includes communications and radios. So markets that Jeff talked about, from industrial to automotive, aerospace, consumer, healthcare. So we have visibility to all of those applications. And within communications, we tend to focus on the infrastructure.
Oh, Dave, are you still there? Oh, I think we may have lost Dave, but that's okay. Why don't we go ahead and move over to you, Charles, if you wouldn't mind, and hopefully we'll get Dave back. Let me go ahead and get up your panel. So while we work on trying to get Dave from ADI back, I wanted to see, Charles, have you talk about NI and what your company's role is in 5G. Obviously, plays a bit of a different role than ADI and some of the other companies that are helping to make 5G reality, particularly in the test challenges introduced by the adoption of 5G cellular networks. Can you give us a quick idea of the role that NI plays in making 5G a reality?
Thanks, Philon. Sure, I would love to. Dave's a super hard act to follow, so this is actually a blessing for me. All right, so if you could just go ahead and go to the next slide. For those of you that don't know who NI is, we're a $1.3 billion company headquartered in Austin, Texas. Put about 22% of our revenue back into R&D each year, 40 operations across the globe. And really our mission is to empower engineers and scientists with systems that accelerate their productivity, innovation, and discovery. On the right-hand side of this the slide, you can see some of the use cases that we enabled in the earliest days of 5G, from the first massive MIMO systems to the first millimeter wave multi-gigabit systems, to all new levels of spectral efficiency, which is a measure of how many bits you can get to the same amount of spectrum at a time. So we've really been working with engineers across the ecosystem, both in the semiconductor industry and outside, to achieve some of the incredible performance gains, at least in the lab, that should be possible to drive the use cases that Jeff talked about. If you go on to the next slide. Not to get too techy, but really there are three use cases that drive 5G. There's the enhanced mobile broadband use case, which is what we all think of as, man, I want faster data rates from my Netflix. But there's also two other ones that, while they're new to 5G yet, we really have not seen the promise and potential of them yet. One is about more density. And really what we mean by that is enabling sort of a cellular version of the Internet of Things. Today, most of our Internet of Things devices attached to our home networks, but that sort of limits the sensing and interaction we can have with our world to what's local to our home or to our office. But really 5G should enable literally hundreds of thousands of devices per cell so that we can literally instrument the world. And the last of the three use scenarios is what we call ultra reliable or low latency communications. URLLC is sometimes the abbreviation. And this is about, hey, if we're going to enable every device, every piece of farming machinery, every automotive, every robot, every drone to self-communicate, our network has got to be far more reliable and far faster than it is today. If our Netflix stream goes down, okay, it's an inconvenience, no big deal. But if a drone or an autonomous vehicle goes down, it can really be the difference between life and death. And so the way our company addresses that is we build a very modular hardware platform and a very flexible software platform. Because one thing about the wireless world is it changes probably faster than any other industry that I work with. There is a new standard literally all the time, whether it's Wi-Fi or Bluetooth or cellular, it's constantly upgrading. And so you need a system that can pliably work with these. So if we go to the next slide, just a little bit more of a survey of who we've worked with over the years to get that new millimeter wave super high bandwidth of 14 gigabits per second. That was a collaboration with Nokia. We've collaborated with Verizon. with a lot of the academics in the world, and then a lot of the big processing companies and operators as well. And really, I think, Falan, you mentioned earlier, man, it takes a village. This is not each company acting on their own. This is all of the companies acting in a community, and constantly working towards the same set of goals. If we go one more slide. So how this actually works in reality is it's not like, boom, a new cellular standard like 5G comes out, but there's a flow in the engineering community. It starts with design and prototyping, meaning how do I take some idea or promise and actually build the first prototype of that thing. Maybe only building one of them. Maybe it kind of works, but it doesn't work very well. Second phase we call validation. This is where you've finally got a prototype. It's about what you want it to do. Now I really need to put it to the ringer and find out the limits of its capabilities in the lab. Then we try to produce that design in very high volume production so that it can end up in the hands of the consumers that we all enjoy. The truth is that 5G is more of a marketing term than it is an actual standard. There's actually a standard behind all of these cellular pieces based out of the 3GPP. But 5G is not one 3GPP standard. It is constantly evolving. And really, there's a new 3GPP standard coming out about every single year. And about 8 of them grouped together will form a G. So there's a new G about every 8 to 10 years. So while you can buy a 5G phone today and it's in the middle of that production to consumer use to field use phase, there's something right behind it, which the marketing label for is likely to be 5G advanced, that is in the prototyping and early validation phases. And then before that, even earlier than that, we're already starting on the very earliest technologies of 6G within the ecosystem and really flushing these things out. So it's a really exciting time. It's a very important time that we're all working together on this sets of technologies. And then the last slide, please. As we look towards that 6G piece, it's kind of a lot of people say, okay, what's 6G going to be? And the truth is, I don't actually know today. That's what we're all trying to figure out as a technology ecosystem. But what I can tell you is 1G and 2G were a pair that really focused on mobile voice communication, phone calls that you could make anywhere. 1G kind of was a little bit wonky and mainly for business users and really expensive, but we figured out how to drive the cost down, how to drive the benefit up, and then it got adopted broadly. Most of us probably had our first cell phones as 2G phones. Then 3G and 4G were a pair, and they were a pair that weren't just about mobile phone calls, they were about connection to data and the internet. And if you remember in the early days of 3G, if you tried to take a 3G phone and use that new data connection or even make a phone call when you traveled, especially internationally, your chance of success was pretty low. You had to go buy a local SIM card to attach to the local network. And by the time we got to 4G, then boom, it's automatic everywhere we go. And we're seeing the same thing. We think 5G and 6G are likely a pair that is not just about connecting data to the internet, which is what we're now all used to. It's about connecting every person, every machine, and every sensor on the planet to a huge ecosystem. And we've seen the early stages of 5G right now. We're still thinking of it as a faster version of 4G. But the truth is we need the ultra reliable low latency and we need the massive machine type communication added together. And what we're going to 6C and 6G is really an extension of those capabilities. We're going to get it right, if you will. We're going to drive the cost. We're going to drive the performance benefits so that in the future, you will be able to see fleets of self-driving autonomous everythings and instant access to all of the sensors that you need in the world anywhere you go. And it should transform, per the promise, life in every industry as we know it, as we saw in Jefferson's slides. But we are still in the very early stages of that technology. 5G is still very infant. And love to at some point in time talk more about 6G, but that's more than we have time for today. So Falan, I think I'll turn it back to you.
All right. Well, appreciate that, Charles. That was really helpful to understand sort of the progression of, 1, 2, 3, 4, 5, 6G. And I think, as you mentioned, sort of 5G being a marketing term, what does it actually mean? And how does it relate to the other generations before and 6G? So appreciate that. I see we have Dave Robertson back on from ADI. So why don't we go ahead and I'll put your slide back on. And
we'll
I know
try this again. And I hope everybody in the webinar appreciates our vivid demonstration of the importance of robust connectivity in our networks. So again, ADI, just real quick summary. We are we're kind of the semiconductor company that lives at the edge. So the edge of the physical world to the cyber internet world, the digital world. And we work across all the markets that Jefferson talked about: industrial, communications, automotive, aerospace, consumer, healthcare. Within communications, we focus on the infrastructure. So not the handset so much, not the terminal as much as the network itself. And so I want to talk a little bit about how semiconductor technology and the advances, what we have to do in semiconductor, are critical and fundamentally enabling for what it takes to get to 5G and beyond. So if we go to the next slide, Alan. So we all think about how important size, weight, power, and cost is in our terminal device, our handset, but it turns out it's enormously important for the radio network as well, for the edge. And we tend to think of the network as the big base station tower we see in our neighborhood or next to the highway. And weight is cost there. So you pay money to haul that weight up to the tower. I've got a great picture of a tower on top of a mountain bent in half because the wind picked up against the antennas and literally bent the base station over. And so as we add more bandwidth, you'll see lots of towers with dozens of antennas on them as networks provide more and more connectivity. There's a limit to that on power and cost. This evolution, where is all this additional bandwidth, all this additional connectivity coming from? Smarter radios, but also more bands. Gen 1 and Gen 2 and the frequency spectrum on that lower left used up to, in frequency bands, up to a gigahertz, 900 megahertz, and then up to 2 gigahertz. And 3G and 4G started creeping up towards 3 gigahertz and above. 5G opens up bands out to 6 gigahertz and even the microwave bands up at 28 and 40 gigahertz. Those are very, very challenging frequencies to work in. The nice thing is there's a lot of bandwidth up there. The challenge is it's a hugely difficult radio to make work, and you typically need antenna arrays. So these greater bandwidths, higher bands mean more antennas, more channels. You need to lower the cost and improve the performance of all of these things. But as Jefferson alluded to, this is not your mother's or father's network anymore. This isn't just a cellular network with big base stations. There's now a variety of form factors. So we have antenna arrays, we have small cells that may be mountable on a lamppost or even indoors in the same places you might put a Wi-Fi access point. So there's a huge variety in the radio. And the idea is to virtualize a lot of the network function just to make it kind of soft, but the radio is still a real hardware problem. There was one question in the chat about all the different connectivity and how are we going to add all of these huge towers. A lot of the additional connectivity that's going to get layered in is in these small cell form factors shown on the left. So it's not going to be all on towers. A lot of these things are going to be literally mounted onto a lamppost, mounted onto the side of the building, and you will be no more aware of them than you are of the Wi-Fi access points that you're using. This is a big, big challenge for the radio. So let's go to the next slide. Let's talk a little bit then about what's inside one of these base stations and whether it's a big box that's the size of a small refrigerator or a small form factor that's the size of a Wi-Fi access point. They've got several different common technologies or common elements that may be built with very different technologies, depending on whether it's microwave or low power indoor small cell. And these use different semiconductor technology. So if we start on the right, moving back away from the antenna, that big dark blue triangle is the power amplifier. That's what actually puts out the radio signal. And that can be anywhere from 40, 50, or 100 watts down to a few watts, depending on the application and the array. Those things tend to get built out of very specialized semiconductor technologies. In some cases, gallium nitride, in some cases, specialized CMOS processes meant for PAs. So those are in specialized fabs, sort of unique to that. The other RF functionality tends to be built in RF fabs, analog fabs, as the SIA kind of refers to them. That's not cutting edge lithography. That's not the very fine deep EUV lithography, but it is sort of specialized and very high performance. Then you move into these big blocks on the left. The light blue radio, this digital front end and transceiver, these tend to be built in CMOS at or near leading edge. So maybe 16 nanometer, 7 nanometer, 5 nanometer, that sort of thing. The blue box, dark blue box next to that is big digital functionality that's in the radio. These things are, again, at or near the leading edge. You'll build those chips, big digital chips, to provide that functionality in your state-of-the-art fabs. And then there's some support circuitry up along the top, the clocks, the power functions, things like that. Again, analog building blocks, those are in the same fabs that tend to run parts for automotive applications and things like that. So what's fascinating is when you pull one of these radios apart, you end up with a microcosm of the whole semiconductor industry, a little bit of everything from memory to very fancy 3.5 technologies. And as we get to 5G and beyond, it turns out that more and more of the functionality of the radio, back in 2G, we had a lot of mechanical filters and physical cavity filters and things like that. And the silicon was maybe half of the bill of materials cost in a radio. In 5G, the silicon is the radio in these massive array systems. There's some very advanced package technologies that are starting to go in, particularly as we push up into the microwave frequencies, that cause some pretty steep challenges. And so I think this is pushing a number of players across the semiconductor industry to really push their technology to the state of the art. But the payback is very, very high. For example, when we think about how green is 5G, the rough calculations are that the energy required to push a bit across the network in 5G is about 1/10 the energy required in 3G networks. Okay, so which is very, very important, because if you think about it, if we weren't increasing the energy efficiency by orders of magnitude, as we push that much more data over the network, all the lights in the city are going to go out because we're powering the network. So this is hugely important. And this leads to a lot of those efficiencies, a lot of those payoffs that Jefferson talked about. So with that introduction, Alan, I'll maybe hand it back to you, and we can handle some questions and get into some discussion between the panelists.
Yeah, sure. Love to. Dave, before I move into Q&A, I want to ask you a quick follow-up, because it relates to what Charles mentioned about it takes a village. And this slide that here at Anatomy of a Base Station, you mentioned it sort of encompasses the whole semiconductor industry, right? Participating to make this happen. Do you have like just off the top of your head, like how many semiconductor companies do you think it typically takes to that are involved in some way or another to create a base station like this?
So they talk about the base station. This picture is the radio unit, which would be sitting right up at the antenna at the top of the tower. And then depending on the structure, there's another big digital function down in the bottom. If we talk about that as the total radio, both the outdoor unit and the indoor unit, or the distributed unit, then there's probably, in a typical configuration, half a dozen to a dozen different semiconductor companies contributing into that bill of materials.
Right, and then of course you have companies like NI that are doing testing and
you've got the radio board builders, you've got the network operators.
Right.
Part of what's going on down off of the antenna is they're trying to virtualize that functionality, and instead of, say, having they're trying to move more and more of what was being done with hard network switches into server functionality. Just like the wireline telecommunications network used to be switch based, and literally they would rewire a set of switches to give me a phone line between myself and you when we want to have a conversation. And now everything's packet based and really handled as the internet. And that's part of the transition to 4G and 5G, is to kind of virtualize a lot of the network functionality. The radio still has to send out real signals. So we
Mhm.
can't virtualize that. That's real radio signals. But part of what's going on now is that the the radio network, parts of that are starting to look a lot more like the internet network.
Yeah, yeah. Awesome, cool. Well, yeah, we appreciate that. We do have some Q&A, time for Q&A, and I encourage folks to send in questions in the Q&A function. I want to just start off and loop back to you, Jeff, about basically about the sort of the everyday changes that we would see in our lives with 5G, and also getting to the idea that, and I think you alluded to this, Charles, you know, it's sort of an ongoing process in terms of its evolution, 5G now, and what will 5G look like in 5 years? And then of course with 6G. So in terms of what the non-expert or regular person's point of view, noticeable changes in terms of affecting people's lives now, what would you contribute to 5G in terms of how it's changed from sort of the 4G? And what would you see like for 5 years, looking down the future, how things would look from a consumer point of view?
I think that from a consumer point of view, initially we'll see speed as the main currency, as Charles had pointed out, right? We'll see faster download speeds. We'll see better upload on the existing form factor of a smartphone. I think that the smartphone, as we mentioned, isn't going to go anywhere throughout 5G. It just simply doesn't become the only device we're really using. So there's going to be a post-smartphone era that we're going to start to see more and more IoT devices kind of pick up on cellular on a 5G network. And from that, you start to see the proliferation in your homes. You start to see the proliferation in the actual world around you, where you're going to start to see more and more devices once we get past some of the barriers. So barrier number one is just, you know, getting past the existing good enough solution. So for example, let's take home, for example. Today, most of your internet devices at the home are connected through Wi-Fi. And that process is while lower in cost and available and standardized almost globally, it's very painful. So you have to go and read, hey, is this going to work on this service or this service? You unbox the device, you have to download an app. We're driving more app fatigue from that. You type in your password so that you can get connectivity. What if the power goes out? Is the actual device going to reconnect, or do you have to manually reset it to get it to connect again? So those simple things, if you think about how the cellular network handles this, we simply took your phone out of the box, you powered it on, the network identified Falan, the network decided what activation and provisioning services you need to get, and you were off and running. It was basically powered on. So as we move into an environment where 5G can handle more devices per square kilometer, as Charles had mentioned, as we move to an environment where we can lower the cost of the modules into the devices and the overall piece of that, as we increase the value that consumers get out of those devices, can we start to accelerate more IoT devices onto a 5G network and avoid the read it, download the app, punch in the password, hope that it comes back online when the power goes out? Wi-Fi is a best effort network, and it's on unlicensed spectrum. So there's innate security and reliability issues with that compared to a truly mobile 5G environment, but we've got some things to get past first.
Yeah, it kind of gets to what you mentioned about 5G requiring more conditioning of the market. I guess that's more the idea. People just need to get more familiar with it and understand its benefits, right? That gets to, there is a question that I thought was kind of interesting, which I think I'll just throw out to all three of you when it comes to the barriers for 5G, because I think I'm getting the idea that, I guess the question is, are the barriers really economic, cultural, or technical? And maybe that may change now compared to 5 years from now, but maybe where we are now is that it may be here in terms of technically being able to be done, and the costs may be, you know, sort of being driven down, but maybe right now it's sort of, again, like you mentioned, Jeff, sort of that cultural, getting familiar with this new technology, or what I have is good enough, so why do I need something, you know, new? When I don't even know if it's going to work, right? So can any of you guys sort of maybe sort of think about and say, which one is it? Is it more economic, cultural, technical in terms of how to
a little bit of each.
A little bit of each.
A little bit of each. I think that I like to think of 5G as kind of coming in two waves. You know, the first wave is kind of that cellular upgrade and the cellular modalities, and the second wave really taps into a lot of those additional applications that Jefferson illuminated so well. And I think, as Charles indicated, the standards bodies keep releasing different versions, and a couple of the most recent releases of the standards were really trying to help firm up that second wave. In the first wave, where 5G deployed fastest was places where the 4G was already running out of capacity. Big urban areas, China deployed very quickly because they were running out of capacity in places. So that there was kind of a strong economic incentive to do that. It's been picked up in other places. The US is deploying, including playing around with some of the microwave bands for new applications like fixed wireless access. So not competing directly with your cell phone, but providing broadband connectivity to your home. Because it turns out that broadband connectivity to your home, the most expensive part of that network is the last quarter mile. So microwave links are an interesting way of dealing with that problem. So as always, where there's a big economic opportunity, we will figure out the technology. So when we ask those questions, you start with economics, which is why it was good to have Jefferson lead us off, kind of start with the economic imperative. The technology is kind of stepping into place. The microwave technology is still young there, and there's a lot of challenges. Connecting things at those frequencies is a big challenge. So I think that the technology is in place, and it's being worked pretty rapidly down the cost curve as the volumes are starting to ramp up. So I think that we're going to see, I think the description that Jefferson provided, which is you'll see it first as in part of your cellular modality, and then there will be 5G, things will be connected through 5G networks, and you won't even know it's 5G. You'll just see smarter devices, things that previously weren't connected, like your farm tractor, are suddenly connected, and you say, what's going on there? And it's 5G driving some of that, but you may not be aware of it. Similarly on the factory floor.
Yeah, or when you buy something new, like you buy a new car now and it just comes pre-programmed with all these bells and whistles that you didn't have in your car that you owned 15 years ago. And you're like, wow, what's all that? And it's, it's all that technology.
Those bells and whistles today don't have that connectivity. I think the vehicle, what they call V2X, vehicle to infrastructure communication, that's still one of those things that's on the horizon being worked on. And I agree with Jefferson that that'll be a big part of truly realizing safe autonomy, is that level of connectivity.
Gotcha.
Yeah, just a couple quick comments.
Yeah, of course, Charles. Yeah.
I saw an interesting chart a couple of years ago about 4G, and it was a chart that showed the profit dollars that the operators, the T-Mobiles, Verizon's, AT&T's got out of 4G, and it was a nice looking curve. And then they kept the axis, they kept that curve on there, and they basically added the profit dollars of new services that came about as a result of that technology foundation being there. Facebook's, Amazon's, Netflix's, all the services that we now stream. And you almost have to put the y-axis on a logarithmic range, and all of a sudden the infrastructure profit almost disappears. And it's just an example of, if all of the operators could have seen the promise of all that, they probably would have taken a little bit bigger piece of that pie. But it's also like, hey, we couldn't see that at that time, right? I mean, we didn't understand. Phones were about making phone calls. And all of a sudden they had this internet connectivity, and okay, that's about communication. Maybe I'll check my email. That's what I did on my BlackBerry. So everybody missed, or a lot of people missed, the benefits of streaming and always on connectivity until it was right in front of them. And the technology enabled a whole bunch of new business models. And so I think it's kind of a fun exercise, given that a lot of us couldn't have seen that transition from 3G to 4G, to ask the question, okay, when we're at 7G, looking back, what are the capabilities that we're going to have that seem extremely obvious at that point in time that today we can't see? And I think as I just play mentally with that question, you get things like, okay, well, I've got a Roomba, which is an IoT device in my home. I have a self-driving tractor that's now limited use, very expensive in the farmland. I start putting that together with some artificial intelligence and machine learning, which is, by the way, being discussed for our cellular networks. And does that mean the end of everybody mowing their own lawn?
Mm.
Right? In
Yeah.
an infinite space, you're outdoors, you may not have Wi-Fi connectivity, you need artificial intelligence, you need to bring that scale down. It's an always on connection, it's safe. There will be things in the future that we all still do today that we just won't do anymore. And I think it's a fundamental exercise to kind of think about those things. What are the profit dollar things that will inflect a logarithmic change on the y-axis of the economic piece? But it takes technology as a base. It takes creativity on the economics, I think, and it takes a cultural shift to expect that I'll never mow my yard anymore.
Yeah, right.
Not just that my phone is a handheld web browser.
Yeah, totally. Very interesting. I know we're getting close to the top of the hour, but I wanted to just loop back a bit on talking about the industry side, because 5G, we talked about consumer sort of benefits and sort of, but as Jefferson, you mentioned, the industry implications of 5G seem to be quite enormous across a various numbers of sectors. And there was an interesting question that came in terms about, what would be the commercial 5G application that could really drive 5G adoption sort of in the industry, in the industrial space, like we're talking about, in terms of video and streaming video, and consumers are like, oh my gosh, like this, my phone can do this. I love this. I don't know what it is, but I love it, right? Is there something that in terms of your analysis, looking across these various industries, where you say, okay, well, 5G applied in these, 2 or 3 industries could really has the potential to really show its benefit, and then could help sort of spur on adoption in sort of the industrial sector?
Yeah, they're so fragmented, Philan. That's the real answer, is that every industry has such a different set of problems and such a different value chain that it's hard to, I probably about 5 years ago, I started this 5G journey, and every client kind of met me and said, okay, so what's the $1 billion use case? Can you just tell me the $1 billion use case, right? And that doesn't exist, right? It's not that it doesn't want to exist. It's very different for every industry, right? So for example, for healthcare, is virtual healthcare, the extension of experience and extension of expertise beyond that, going to be the one that drives it forward? Because now that we're allowed to, the insurance companies are able to pay for that, is that going to remain? There's so many factors that could change this. If insurance companies say, hey, we're in certain countries, we're not going to pay for this anymore, you do have to go in person, that was just a blip in the screen, well, now we got a big problem in the value, right? For autonomous driving, same thing. If we're getting to L4 and we're getting to an L4 autonomous driving scenario, if certain states say, like, I'm not okay with that, right? Now we've got a problem. We've got a fragmentation issue. If in manufacturing, manufacturing itself, discrete manufacturing versus regular manufacturing versus within discrete manufacturing, are you doing, furniture, or are you doing products, right? So every one of these is so fragmented. I can tell you the one that I think will work in each of them, but we'll run out of time. So rather, it's think about it from a technology perspective. What are the pieces of horizontal technology that can generally serve all of these things, that takes advantage of the network, is the way to think about it. It's how I guide clients, right? Video takes up a pipe. There's a very big and fast pipe. Analytics makes decisions quickly and can actually sense, comprehend, act. So if you put those together, video analytics makes a lot of sense, because it can take advantage of the network, and it can take advantage of what we're about to provide and put out there. So now, how do you solve problems with that? Again, then it becomes understanding the industry issues, right? So for example, you could solve worker safety through sensors. You could solve it through video analytics. You could also solve it through just being more careful with protective equipment. But how do you actually, if you're trying to solve for a problem, what are the horizontal technologies? How do we actually take advantage of the tech? And then how do you apply the industry lens to it to solve it?
Well, one way to think about that is, if you think about 5G as a potential enabler of automation across a number of different industries, and a lot of times automation requires a level of connectivity, and not just a few bits of connectivity, wideband connectivity that's mobile, that's robust. So whether you're automating a factory, whether you're automating a vehicle, a bunch of that, really, to make that work in a safe, robust way, requires some very secure, very reliable, low latency connectivity. 5G is an enabler of that. It's kind of order of magnitude improvement over what you can realize with, say, Wi-Fi. So I think to flip the question around a little bit, sort of think about the things we've been talking about automating for 10 years, 20 years, and gee, but that has never happened. What will it take to make that happen? 5G in many cases is the kind of connectivity that provides that missing ingredient that could finally allow us to realize some of those automation promises that we've been talking about for a couple of decades now.
Yeah, and one thing I would also occurred to me just mention is what the market needs at any particular time. You know, in terms of this past year, I mean, I would think that video conferencing technology like Zoom has probably been around well before the pandemic, but pandemic hits and my God, the market needs something, and it's been around for a while actually, and now we're just all using it because we need it. So. Who knows if God forbid we don't have any sort of pandemic again or something like that, but you never know what in terms of where what the demand side of things will require, and it may be it may help sort of show the benefits of 5G that are there, that exist currently, and people will say, oh well, now it's here and we need it. I know we're a minute over. I think we could be here all afternoon talking, which would be amazing in terms of the questions and sort of where 5G is going and what it can enable. It's a fascinating story, and I think we'll probably be one we'll be talking about more about 5G, and obviously in the future when we get to next generations as well. I want to just thank you all, the panelists, Jefferson Wang of Accenture, Dave Robertson of ADI, and Charles Schroeder of NI. Really appreciate your insights, and thank you for taking the time to participate in today's panel.
Thanks for having
Thanks,
us.
Falon.
All right, take care, everyone.
Thanks, everybody.